What's up guys, in this video we are going to solve the we are going to actually find the derivative of a composite function. We are going to continue the exercise 3.1, right? So in this video we are going to solve the question number 2, which says that find dy by dx if the first one, y is equals to log of log x, right? So we are continuing the exercise 3.1, and here we need to find the derivative of y with respect to x if y is equals to log of log x, right? So to write an answer, I'm going to again write the question here, log of log x. What we are going to do here, we are going to assume that u is equals to log x, then y is equals to log u, right? So log x becomes u, so y is equals to log u. And here we are going to write differentiating with respect to u, we get dy by du is equals to d by du of log u. And we know that the derivative of log u is 1 upon u, right? So therefore, dy by du is equals to 1 upon log x, right? Because u is nothing but log x. So I'm going to substitute the value of u here itself. So let's find the derivative of u with respect to x. So we know that u is equals to log x, differentiating both sides with respect to x, we get du by dx is equals to d by dx of log x, and we know that the derivative of log x is 1 upon x, right, with respect to x. So this is going to be 1 upon x. By chain rule, by chain rule, dy by dx is equals to dy by du into du by dx. And the final answer is 1 upon log x into du by dx is 1 upon x. So the answer is 1 upon x log x. This is your answer. This is your dy by dx, right? So we are just continuing finding the derivative of the composite function, and this is how you do it. You assume uh, the composite part to be some variable. In this case we assume it as u, and then we find dy by du, and then we find du by dx, right? But guys, instead of assuming like assuming some variable u is equals to the log x, we can solve in a different way, right? We can solve in a different way. I'm going to show you that. So I'm just going to continue this exercise, continue this question. So in another way, I'm just going to continue here. Y is equals to log of log x. So to find derivative, what you will do is differentiating both sides both sides with respect to x. So to what will be it? How this will look? Dy by dx is equals to d by dx of log log x, right? This is how it will look, right? And we know that the derivative of log x, the standard function, d by dx of log x is 1 upon x, right? But in our case, x is nothing but log x. So the derivative will be 1 upon log x, right? Remember that this is, as the x is log x, or rather a composite function of x, you need to again take the derivative of log x. This is very important, right? What let's rewind. So to find dy by dx, what you are going to do, you are going to have d by dx into f of x. In our case, it's log of log x. So we are going to apply the log derivative, which is 1 upon log x, because here x takes the value of log x, and then we are going to again multiply d by dx of log x, right? So the answer would be, this is, don't get confused with the x, this is important. So the answer would be 1 upon log x into derivative of log x is 1 upon x. So the answer would be x into log x, right? Rather than letting u is equals to some composite part and then finding dy by du and then du by dx, you can directly solve this the derivative of this composite function using this method as well, right? This is also a valid method, right? And this is short, sweet, and simple. So basically, for example, let's deep dive, go into deep. For example, let's say that you have y is equals to log 2x. This is not a sum. I'm just walking you through an example. So the dy by dx would be d by dx of log 2x, right? And we are going to apply the derivative of log x. So in our case, 1 upon 2x into d by dx of 2x, right? And the answer would be 2 upon 2x, and the answer would be 1 upon x. Remember that here, instead of x, if there is some composite function of x, you need to again apply the derivative of that composite part. And this is also a chain rule, right? You find some derivative into d by dx of the composite part, right? So this goes by a chain rule method as well, right? Also similarly goes for e raised to, let's say, 3x plus 4. So the derivative will be e raised to 3x plus 4 into d by dx of 3x plus 4. And the answer would be 3 into e raised to 3x plus 4, right? Because the derivative of the composite part would be 3 and the constant derivative will be 0. So we have 3 here. So 3 e raised to 3x plus 4. This is just an example. I'm just showing you how this works, how this chain rule works, right? Rather than using the u variable and finding dy by du and then du by dx, you can use this method as well. And we are going to use this method for the rest of the exercise, right? So let's go to the second example. The second example is y is equals to log of 10 x raised to 4 my plus 5x cube minus 3x square plus 2, right? So we have this. So what we are going to do is we are going to write again this y is equals to 10x raised to 4 plus 5x square minus 3x square plus 2, right? Sorry, instead of 5x square, it's 5x cube. So I'm just going to write it again. So instead of 5x square, it's 5x cube, x cube, sorry again. So we are going to write log of 10 x raised to 4 plus 5x cube minus 3x square plus 2. So what we are going to do here, we are going to differentiate both sides with respect to x, right? So dy by dx would be d by dx of log of 10x raised to 4 plus 5x cube minus 3x square plus 2, right? So what will be the derivative of this, right? So as this is log, this would be 1 upon x. So in this case, x is 10x raised to 4 plus 5x cube minus 3x square plus 2, right? We are not done yet. We again need to find d by dx of this whole part, which is 10x raised to 4 5x cube minus 3x square plus 2. This is very easy. You need to find first the derivative of log x, and again d by dx of whatever that x term is, right? This is nothing but a function of x. This is a composite function. So what will be the answer for this derivative? It will be 10 into 4x cube, right? 4, and this is of the form x raised to n, so n into x raised to n minus 1, which is 4 into x raised to 4 minus 1, which is 4x cube. Similarly, 5 into 3x square minus 3 into 2x, right, plus 0. This is the derivative upon 10x raised to 4 plus 5x cube minus 6x plus 2. The final answer would be 40x cube plus 15x square minus 6x upon 10x raised to 4 plus 5x cube minus 6x plus 2. Okay, so I made a mistake here. So instead of 6x, it's actually 3x square. So here would be minus 3x square, and here would be minus 3x square. Right? So this is your dy by dx. So this is your final answer. It's very easy, right? There is a pattern. You need to understand that pattern. And this would be your final answer. Okay. Again, we are going to solve one more question. This is going to be the last question for this tutorial. And we have y is equals to log of ax square plus bx plus c, right? We have y is equals to log of ax square plus bx plus c. So to solve this, we can write here, we or rather we can say that given, instead of writing, we can say that given y is equals to log of ax square plus bx plus c. So what we are going to write next step, differentiating both sides with respect to x, we get dy by dx is equals to d by dx of log of ax square plus bx plus c, right? What will be the derivative of this? This would be 1 upon ax square plus bx plus c, right? By chain rule, we need to again find the derivative of the inside part, which is ax square plus bx plus c. The answer would be ax square plus bx plus c, and the derivative of this part, remember this is addition, so derivative will apply to each term, and the answer would be into 2ax, because this is of the form x raised to n, plus this would be b, because derivative of x, this is of the form, remember, when we find d by dx of x square, this is basically like d by dx of 1 into x, and we know that d by dx of kx is k. So here, as in this case, it is 1. That's why d by dx of x is 1. Right? We have seen that in the second class. Derivative of kx, so here k is equals to 1. That's why d by dx of x is 1. Right? And derivative of constant is 0. So the final answer would be 2ax plus b upon ax square plus bx plus c. This is very easy, right? Just understand how you apply a chain rule. Okay, so I'm done with this class. In the next class, we are again going to continue with finding the derivative of the composite function, and we are going to solve the question number 3 of your textbook. of exercise 3.1. So I'll meet you in the next class. Till then, goodbye and see you.